Okay, so this is for anyone who wants to contact me on Twitter. I am not your broom. Brief intro, but something that Fiona didn't mention and David didn't know when he asked me all sorts of obscure questions so that he could pull out random facts at the beginning, is that when I was young also, this was one of my favourite books. And what has happened to the colours on this screen? Because that's not what it looks like here. But I'll carry on regardless. So Dr. Seuss, if I ran the circus, and so I was looking for a gimmick for my presentation. And so I went with Gradient Circus. Now, there's been a lot of talks and articles, things about how to use gradients in CSS. I'm not going to rehash what a lot of them have already done. Instead, I'm going to dig into kind of how they work and some of the tricks that browsers use to optimize them. But first, like with any circus, you need to introduce the performers. So we have two basic types of gradient. You've got the linear gradient, radial gradient, and then you can have like a standard version or a repeating version. I'm sure a lot of us have used online gradient generators where we pick some colours, and it generates a list of about 7 different prefixed versions of a gradient. You don't actually need to do any of that. Use it unprefixed or don't use it at all, because that's what the browsers today support. So this circus will be in 4 acts, and on to Act 1, the tips and tricks. So these are some interesting things you can do with gradients. Leah Veroux has collected a whole heap of different patterns that you can build, such as bricks and lined paper, blueprint grids, all just using a single element and variations on gradients. So someone then took on that role and went, what if we combine it with a new background blend mode, and came up with a whole heap of new variations. You don't actually see these in practice all that often, but they're interesting experiments. Speaking of interesting experiments, so this went around the internet a few months ago, called a single div. It's pretty much someone's art project where each of these pictures is just one single element, and they've used a crap load of gradients and box shadow to create all these pictures. This in turn inspired someone to create the Gradient Inspector Chrome extension just to work out how they actually did it. I was going to show a demo of Gradient Inspector in this presentation, but in the process of doing the slides for this, I actually managed to break it in about 3 different ways with edge cases, so I'm got to submit some pull requests to fix that up. This is also an interesting one I saw just recently, which is a tool to, on your server side, look at the images you're about to send out to the browser and actually generate some gradients based on the colours in the image as placeholders while your images are loading. So if you move on from that, you kind of think, well, all right, what if we wanted to animate the gradients? Maybe. Basically, the original spec for background image said that you can't animate it at all. Newer spec says you can in certain ways, and the browsers just don't really care. So if you actually want cross-browser animation of any kind of background image, you can't. Hopefully they'll actually fix that, but there's been no progress since this exact support matrix was published by someone else 5 years ago. But speaking of specs, there is a future spec coming. It's currently in draft mode, and it has conic gradients, which is a brand new gradient type. The browsers are a bit lax on actually wanting to support this, but we'll see where it goes. So conic gradients are not to do with a washed-up 90s actor and musician. They are, in fact, something like this, where instead of going in a gradient going along a straight line, it's actually going around a point. So this is all due to the work of Leah Veroux, where a few years ago she proposed a rough spec just on a personal space, and that then turned into a draft spec with the W3C. 2 weeks ago at CSS US, she launched a polyfill using SVG and PNG, and the colours on this screen are incredibly bad. Basically, you can use it for hue, wheels, and colour pickers. You can use pie charts just using a single gradient definition. What she's actually asking for is for people to go use the polyfill go harass the browser vendors and say, we actually want this in the spec, you need to implement this, because they're not going to implement it unless people complain about it. So that's a brief overview of some of the tips and tricks you can do. One last thing you can do with conic gradients too is the background of these slides. But we'll move on to linear gradient angles. Now, I would actually go into details, except that one of the lead developers on Firefox DevTools already has, and there is a great big detailed article on Medium where I'll send around links after this, because it's a fantastic article giving just about everything you could possibly want to know about how angles and gradient lines are calculated. And he also gives a link to this tool he created on CodePen, where basically you can go in and start tweaking the gradients and see exactly how the line is calculated and how it creates the gradient so that the corners will always match exactly what you say, and basically show what the browsers are doing internally. So he's covered all of what I really wanted to say about linear gradients, so I'll just move on. Now, background image layering. This is a technique that pretty much all the gradient patterns that we saw in the galleries before, they use this to great effect. And it's one of the things that confused me a bit when I was first looking into these, because if we think about, if you're drawing a painting in real life, you would get your canvas and you'd put down to the background colour, say, you know, like a nice blue wash for the sky, and then you slowly build up details from the back. So you'd put trees and then you slowly build up to the foreground. And that's not actually how you do it in CSS with images, because you can do multiple background images, but they layer the background colour below and then all the images from the top down. So what it actually looks like, if you split it out, is you have a URL, then a linear gradient, then a radial gradient, and then the background colour. Now, if we actually sandwich those up, this is pretty much how they're stacked by the browser. So you need to make sure that your top image has enough transparency for the bottom ones to come through. So it's just kind of a flipping the direction of your thinking when you're trying to construct them. This, in turn, can get combined with things like background size and background position. So a lot of the really kind of geometric patterns that are used take advantage of this. So if we were to define, say, a linear gradient, radial gradient from this corner up until here as transparent, and then just fill the rest, you would actually fill this corner as well, but we want that to be transparent. So the technique is to actually create two gradients at 60% width, so they overlap, and then when they get sandwiched together, they look like one smooth image. And this, once you've learned these tricks, this is pretty much the basis of every single one of those fancy gradient gallery images. So that's brief overview. First 3 acts, they were all just leading up to the main event, which was really the thing that actually led me to propose the talk for CSSConf in the first place, which is when I was trying to work out how they did the color calculations in a gradient, and it drove me mad, and I just funneled the anger into a talk proposal. So, looking at it, a basic example, we have a gradient that goes from a blue to a red, and it's defined like this. So we're using the HSL syntax. So hue, saturation, lightness. We go from 220, which is a nice blue colour, down to 0, which is a red. And you'd expect, all right, so the browser looks at HSL, same syntax, so it should just go from 220 to 0, and then maybe put the lightness up from 50 to 60%. And I've seen people get caught out by this, because the very first thing that a browser does is convert it to RGBA. Every single colour calculation done by a browser, whether it's a gradient or animation of a colour, is always done in RGBA space, and that is in the spec. So it'll start looking at each one of these channels. So red goes from 13 to 245, green goes from 89 to 61, and so on. So if we take an example at 50% here, then we can actually see it's like halfway between 13 and 245 is 129. You get this kind of purple colour here. So as I said, this is the same algorithm it uses for if you're transitioning a background colour or a foreground colour using animations. They actually use the exact same code paths in the browser. Now, this is the one that it has caused a lot of developers pain in the past, which is transparency. The spec actually changed because so many developers complained that it didn't do what they were expecting it to do. Now, it's kind of a bit harder to see on this screen. I'll see if I can zoom in a bit. The one on the left actually has a few darker patches than the one on the right. And the reason this is because if you could just go red to transparent to blue, the browsers interpret transparent as an alias for fully transparent black specifically. So what it's actually doing is as it's going from red to transparent, it's actually going from red to black at the same time that it's fading it out. So to fix this, the browser vendors got together and they talked about the spec and they introduced a new version of the spec, which brought in something called pre-multiplied alpha. This is a term from computer graphics and a lot of the really hardcore image processing techs were on to this. And now we have an interesting split, where Canvas and SVG always use the old style because they're not using CSS gradients and they provide a lower level control over your colour. And Safari just doesn't want to update anything. But Chrome, Firefox, IE, they've all gone to the new spec, where if you go red to transparent, it will always just fade through a red colour. If you want to mimic it in Safari, you have to define two different colour stops. One is, so for here example, we've got red through to a fully transparent red, then it instantly switches to a fully transparent blue, and then goes up to normal blue. Now, what the hell is pre-multiplied alpha? This is the question that I started investigating a while ago. Well, there you go, simple. My investigations led me to the CSS compositing and blending level 1 spec, and it's given us that formula, and now everyone understands what it is. There we go, job done. All right, let's actually have a look at it in a different way. So we have, allegedly, a red square on a white square. The red is defined as 255, so full red, but 60%. So it's got 60% alpha, 60% opaque, 40% transparent. If you use a colour picker on this square, you're not going to get that value. You're going to get an RGB value, fully opaque. How does the browser determine what that colour is? And this is where the basics of blending come in across computer graphics. But basically, you take the 0.6 and you multiply each of the channels by 0.6. So you've got 153, so that's 60% red. Then you take the background colour and you take the inverse of this. So you've got 1 minus 0.6 is obviously 0.4. So you multiply each of the channels by 0.4 and then you add them together. And this is what the browser gives you. So if you inspect that colour, it's full red, 40% green, 40% blue. That's all they do. All right. Now, the spec does say at some point it could be more efficient to store a pre-multiplied value. Again, what does that actually mean? Tell you what, this actually works for me. So we got red 255. So we've got full red, but half transparent. And we go down to a full transparent. Now, there's actually a slightly darker version on the top and a more red version here. So if you look at the browser, you're going, all right, I want to go from red here to no red here. So if we kind of graph this out over the course of the gradient, you've got the red just going along like that, and you've got the alpha going along there, and at each point, the core graphics library, whichever one a browser is using, it depends on the operating system, depends on the browser. At each point, it's got to go, all right, how much red do I have between here and here? Now, how much alpha do I have? Now I multiply them together, and you get this kind of dark curve here, and then add it to the background, and that's where you see this kind of dip. Like if I quickly switch there, you can actually see it's kind of calculating, And it's got 3 different values. And what it actually calculates is that it's dip, and that's why it gets darker across the colour. Whereas pre-multiplied is the browser just kind of going, all right, I'm going to calculate this first. So this is now half red. And at each point along the gradient, whatever the core graphics library is, don't worry about multiplying it by the alpha. I've already calculated it. Just go do what I tell you. And this is why it doesn't actually have to do this calculation again and again across the course of the gradient. It just smoothly goes from one point to the next and no color curves. So where this actually produces some interesting effects is when you go from one color to another using partial transparency. And again, the spec is fantastic for browser vendors, terrible for us. So we'll actually show. This is a full red through to a blue with 20% opaque. And the two, you can even see on this screen, are very, very different. And this is the old spec versus the new spec. And again, you can see the color curve of the red as it kind of gets darker. The blue would actually be inverse of that. There's more blue that comes up, and this is where this comes in. Whereas the pre-multiplied version just goes straight from this amount of red to this amount of red. There's no kind of fluctuations as it goes through. This, I actually had to reverse engineer from the browsers before I found that blending spec. I wish I'd found the blending spec first. But now I know a hell of a lot more than I thought I would about pre-multiplied alpha. I've bored you enough with maths, I think. Like any grand circus, though, we have to finish with the big final act. So if we go back to the layering, and we think of the linear gradient angles, and we kind of build on that, and we think if we can calculate the exact length of a gradient line, and we can calculate size and position, we can work out how to make, say, a 5-pixel wide line on any particular angle using only gradients. Then we can build together a series of background images. And you can keep building up and keep building up using all sorts of different types of gradients. And eventually, when you sandwich them all together, and then you collapse them up again, you can make some very interesting artwork. Thank you very much.